everyone, welcome to my analysis on ABC call volume trend. In this video, I will be presenting the key insights from the data, focusing on the call volume trend and manpower requirements. So basically, I will be highlighting the peak hours, additional staffing that is crucial, and the periods of stable demand, the times where the resources can be optimized. Additionally, I'll be sharing the recommendations on how effective scheduling and continuous monitoring can help reduce the abandonment rate and improve the customer service efficiency. So let us dive into the details and discuss how this analysis can guide better manpower planning. So I think the presentation will be visible. Okay, just let me see. Yeah, it is. So agenda is we will be first discussing on the introduction, what is our project description. The third will be the approach that has been taken to complete this issues that have been arises in our ABC call volume trend. I will be telling you the tech stack that is used and the reasoning behind choosing this. The next step will be the insights what we gathered from the like our graphs or any analysis, any kind of analysis, and finally we'll be discussing all the conclusion. So this is the agenda for today. I will be side by side representing you my Excel sheet. So first, let us talk about the introduction to the customer analysis. So customer experience, CX, we called in shortcut customer experience analysis, focusing on understanding the customer interactions to improve the satisfaction and engagement. In this project, the data comes from the inbound call centers at ABC Insurance, where call agent manage customer support. The primary goal is to analyze the call trends, reduce the abandonment calls, and plan manpower accordingly. Inbound support includes receiving calls from the existing or prospective customers, focusing on resolving issues and building the customer loyalty. Let us talk about the project overview. So the dataset spans 23 days and includes the key details like agent ID, unique time, call duration, call status, answered, abandoned, transferred, etc. These are some highlighted columns which we will be performing the analysis. The approach is to analyze the average call duration across the time buckets. For each time bucket, the employees that are working, visualizing the call volume trend by time of day, planning day and night shift manpower allocation to reduce the abandonment calls. So here the goal is to reduce the current abandonment call rate of 30% to 10%. We approach the project by dividing it into four key tasks. First, we will be understanding the data. So it is very important to understand our data in case to look for the problems that is arising that ABC call volume trend. Second, we will be doing a call duration analysis where we will be doing the calculated average call duration for the each time bucket. Third, we will be doing call volume analysis. So here we'll be looking for the visuals to show call volume trend by time bucket, where the calls is getting higher in which time bucket, where it is low, so that it will be easier for us to plan the manpower allocation in that bucket to reduce the call abandonment rate. Fourth, we'll be discussing on manpower planning, that is day and night. So our main agenda is to calculate the number of agents required to reduce the abandonment call rate to 10%. I will be using the Microsoft Excel here. That is the latest version. We have been using for the data analysis and visualization, graph and charts. The reasoning for choice is familiarity. Excel is the widely recognized and used that is making it easier for the stakeholders to understand and replicate the analysis. Versatile Excel provides a range of functions for the data cleaning, analysis, visualization, making it all and making it all an all-in-one tool for the project. The data management Excel can efficiently handle the data set that is here 1,17,988 observations, perform advanced calculations for more complex calculations such as the manpower planning and agent shift optimization. So for these purposes, we'll be using the Microsoft Excel. And again, this has been asked by our, just let me check. Yes, as it was also been required by our uh, organizations to use the Microsoft Excel. So Excel workbook hyperlink is there. If you click just here, it will be redirected you on the hyperlink. It will redirect to you my Excel sheets. So like how we are doing the calculations, what are the steps taken, how you use the pivot table, and any another graphs that has been using. So how the steps has been calculated. So for that, I will recommended you to go and check out all those steps. I will be also discussing how I have executed all those analysis on the Excel. So let us talk about the first task that has been average call duration. So this is the representation before coming into the insights. I will be highly interested in showing my Excel sheet. So just give me a second. I think that will be visible to you. So this is the average call duration in each time bucket. You can see how we had executed this. Yes. So it will be visible, I think. Okay, perfect. So as you can see, we have the these columns like agent name, ID, customer phone number. So what we did, we dropped the time bucket in our rows, and frequently we drop the average call duration, like call seconds into the values, and then we change this to average because we are looking for the average call duration in each time bucket. So this was it, and also we drag the call status in the filter so that we will be only seeing the answered calls here, not the abandoned or transferred calls. So answered calls, we are interested in looking for the answered calls, right? Secondly, after selecting these columns, we drop into a very nice column chart, and we named it average call duration in each time bucket. So on the x-axis, you can see that it is representing as the time bucket, and on the y-axis, it is representing as the average call duration. Let us talk about the insights that can be derived from this analysis. So we can see very clearly the peak durations that the highest average call duration occurs from the 10 a.m. to the 11 a.m. and 7 p.m. to 8 p.m. with 203.41 seconds and 203.33 seconds respectively. So evening spikes, if we'll talk about the evening spikes, the call duration remains consistently high in the evening, especially from 4 to 9 p.m. If you look onto the graph, you can clearly see that from 4 to that is 16 to 17, it suddenly increased to 200.87 average call duration, and then it goes to 202.25, 202.55, and it's then drop when it come to the 90. So 4 to 9 is the evening spikes where there is a good call of durations for the agents. So here we will be needing more agents. Efficient afternoons, shorter call durations are observed in the early afternoon, especially from 12 to 3. That is easily visible here. That average call duration here is 192 from 12 to 1, then 194.74 in 1 to 2, and 2 to 3 is 193.68. So there is a drop in the afternoon calls. Takeaways, what are the takeaways or results from these observations? So the more agents are needed during the morning, that is 10 to 11, and in the evening, basically 7 to 8 p.m. due to the longer call durations afternoon. And shift can be optimized with the fewer agents, afternoon shifts. So we can easily switch our afternoon shifts with the fewer agents. That will be not a big deal. Let us move on to the second analysis. That is the call volume analysis. So in this call volume analysis, first let us talk about the Excel sheet. Like what are the steps taken to calculate this. So you can see, just give me a second. I don't know what is going wrong. Well, it will this. Yes. So on the rows, again we have dropped like time bucket. On the values we have dropped the total calls. So we have a here you can see the count of like customer phone number. So to find the total calls, like what are the total calls, we are using the customer phone number. The count function is again used here to calculate the total number of calls. Again, we what we did it we changed to count of total calls and we dropped again count of like customer phone number to the values and then we set it to the percentage of total call received. So 100 is basically our like 100% is basically our total calls received in the 23 days, that is 1,70,980 in it, and out of that what is the percentage we are receiving. So we also interested in getting this because percentage will clearly determine that what is the highest, what is lowest, rather than looking on the big numbers, because this is not only 5 10. So we actually did it here. Again we can see that this times we are looking for the all types of calls, that is abundant, unanswered and transferred, all the calls, right? So let us talk about the key insights from this analysis. Yes, so here we go. So the peak call volume, so the highest call volume occurs between the 11 a.m. to the 12 p.m. You can definitely see it here that we are getting almost 12.4% of the total calls and 11.28% of the total calls in 10 to 11 a.m. So 10 to 11 and 11 to 12 p.m. So these are the our peak call volume. The number of calls is very high here, and obviously the decline the number of calls that will be declining will also be high. Declining volume, all the call volume steadily decreased after the 12 p.m. with the lowest duration 8 p.m. to the 9 p.m. So after our 12 p.m. the calls are, you can see clearly that it has been just decreasing. Like 1 to 2 it goes to the 9.8, then 8.95, 7 point something, and then it crossed to the 6.13 in our 6 to 7, and it subsequently dropped till it comes to the like 8 to 9, and then after the night shift is over, sorry, the day shift is over, and then in the morning like 9 to 10 it again increases. So this is like that. If you talk about the night calls, the calls rise again between 9 p.m. to 10 p.m., but the volume is still lower than the day peak, right? So what are the takeaways? So allocate more agents during the 10 a.m. to the 12 p.m. During the 10 a.m. to the 12 p.m., more like agents will be required here, and fewer during the evening hours, especially from 7 p.m. onwards. So after 7 p.m. we can reduce the number of agents this time. That will be not a big deal because the customer are calling very less after that, after our 7 p.m. Now we'll be interested in saying, okay, you are saying me that number of employees should be required more in like 10 to 12 or some another divisions. But what are those employees? What are those employees to reduce the number of abundant calls from like 30% to only 10%? So for that, we have created another calculations here that has been required by our organizations, Trinity, that is manpower planning in the day shift, right? So before explaining this and coming to the insights, let's talk about the calculations in the Excel sheet. So the manpower planning. So we can clearly see here, as it was already been given in our sheet that 30% of calls are getting amended, and we can also see it using the Excel or pivot table here. That we the answered calls is 69.88%. The transferred call is 0.96, which is almost 70% answered and transferred, while the amendment being 29.16%, that is closer to 30%. These are the graphs which has been showing, okay, what is the like abundant calls and the transferred calls. So we can see it here that in 10 a.m. to the 10 a.m. to the 12 p.m. the number of like abundant call is very higher, and then also in the like morning time, like 9 to 10. So 9 to 12 should be the duration where the number of abandonment call is very high. The customer is calling, but they are not getting their solutions. So this is again a very big problem for us and for our company to become success, because if the customer is not satisfied, then obviously the market is going to be down. So how we can plan our the agents to reduce this abandonment call to the 10%, right? So assumptions which we have been taking here is that the agent, one agent work schedule. Assumptions and key points here is that suppose the agent works 6 days a week, right? One is the week. In each agent takes 4 unplanned leaves per month, right? So the total actual working hour per day is 9 hours, in which is a half hour of breaks is included. So its total actual working hours per day is 7.5 hours. So on an average, agents spend only 60% of 7.5% on calls. Maybe on other factors like system downtime in meetings or waiting for the call durations, right? Waiting for the another calls. So the agent is also spending 5 hours on a day. So that means it is only 4.5 hours on calls per day, right? Again, we have used another calculation, that is average of call seconds in answered is 198 meter, and the transferred is the 76. The count of customer phone is that is coming. The number of calls is 82,445, and the transferred calls is 1133. Okay, that is all good. That was just to visualize, but let us talk about the number of employees that is required. That was also important to see. Again, we cannot make any decisions. So right now, here another pivot table is used here, in which on the row level we have got the like our time bucket, that is you can see here, and the sum of the call seconds. So I am interested in getting the total number of like work, because we have been getting the 23 days. So what is the total work that is the employees doing to achieve the 60% of the target, right? So the total sum of calls in seconds that the employees are doing is this much. You can see the number here, that is grand total, and that is the percentage total, that is 100%. So now I divide into like 100% according to the values, that is the sum of call duration in each time bucket into the percentage value. So that when we get the actual employees, suppose to calculate the achieve our 90% of target, So how we will be distributing our employees to get those like our like to come over our problems for each time bucket, because we know that in some buckets the number of calls is higher, that is in 10 to 1 a, then it subsequently drops, right? So how we should be distributing our employees to achieve the lesser number of abandonment calls, that is the 10%. So for that we have calculated this, and now let us talk about the total call duration for the 23 days. So this is again, we have just copy and pasted that total number of call duration. This is our total like work. So we should be interested in converting into hours. So we use the like function, that is the total call duration for the 23 days divided by 3600. That is, we first divide into the like minutes and then we divide into the hours. So this is our total works in hour for the 23 days. So what is the 1 day work of the employees? That is he is doing 60% of the work. So for that we divide the total work the total by the total working hours of the employee or agent in a 1 day, that is 4.5, because the agent is supposed to do only 4.5 hours per day work, and then out of the 23 days, so what is an average work for a 1 day? So we divide it by the 23 again. So we got the result, that is 44 employees is currently in our organization that is doing the 60% of the work. But we are like getting the 90% of the work as in, that is 60 is equal to 44, because 60% of the work is equal to 44 employees. So what is 1% is equal to, that will be equal to 44 by 60, that is 0.73. So 90% is equal to what? So 90% is equal to our 0.71 into 90. So that is 66 employees. So if we have the 60 employees, then we will be able to complete our 90% of the work, or reduce our abandonment calls from 30% to 10%. Okay, we have achieved it. But how we should be distributing it to the employees in this time bucket? So for that again, it has been discussed that this is our sum of call duration in percentage. So we will be using this percentage, that okay, we have got it. So we again copy and paste here the percentage of call duration, the time bucket, and the manpower leader. So you can check it here, that in each time bucket we use the total number of employees, that is 66, as the 100%, and then we divided it into 7.88%. So this is again in like a round function. So then sorry, in decimal function, so we use the round function of the Excel to calculate into the nearest integer, because employees cannot be in the like decimals. It can always be in the integer employees, because employees cannot be 1.5 employees. So we can see after like calculating this total employees, if we do some function from here to here, press enter. So 65 employees we are needed. So one employee has been not due to using the round function. So again we drag and drop the time bucket and the manpower from above, and then we switched into a very nice bar chart. So let us come to our like what are the key insights from this visualizations, right? So the key insights, the peak time. The peak time is observed to be 10 a.m. to 2 p.m. that requires a total number of agents, that is 7, indicating the high call volume. Initially what we were thinking that okay, we should be needing 9 to 11 or 9 to 12. But when we come to the sorry, we should be needing 11 to 2 p.m. That is maximum number of requests 7, and then stable demand that is 2 to 4 sorry 2 to 6 p.m. That is 6 agents showing a consistent call activity in 2 to 6. The lowest need is from the 9 to the 10 a.m. and 7 p.m. to 8 p.m. with only 4 agents. And optionally, we have a very lower number of agents needed that you can see from 8 p.m. to 9 p.m. That is only 2 agents. So evening trends is getting down and the morning is high. It, evening trend that is 6 to 8 p.m. So the slight drop to 5 to 6 agents that is indicating the reduced evening demand. And optimizing stream, if you talk about the optimized staffing, so increase events during the peak hours to reduce the abandonment rates. Okay. Let us come to the last task, that is the manpower planning in the night shift. So this was again easy after calculating the task number 3. Let me show this in my Excel sheet. Okay, very fine. As we know that currently in our company, in our ABC call volume, we are only having the employees in the day shift. That is 9 to 9, right? 9 a.m. to 9 p.m. But we know that as it has been given that there are customers which trying to connect at the night, and that percentage is 30% of the total day calls. Again, the distribution has been given here. If you look over the middle chart or the middle graph, or what we can say middle table, the table here that is colored with the green or blue, the distribution of 30 calls are given out of the 100 calls. So in 9 p.m. to 10 p.m. it is 3 calls, 10 to 11 p.m. it is again 3 calls. If you move 11 p.m. to 1 p.m. 2 2 calls, right? Percentage of distribution of 30 per night is like this, and it again subsequently drop in the middle of night, then after increases in the morning and at the starting of the like day day employees, day employees or day shift. That is 8 to 9. That is the 5 calls. So we again like converted into the percentage. So how we converted? We know that 30 is equal to 100 here. So 1 will be equal to 100 divided by 30. Again, so that 1 will be equal to 3.33. So the employees required is, what is the employees required here now? So we can say the employees required percentage is 1.7%. When we convert into the round percent, because before coming to the employees, let me show that how we calculated the employees, right? So we can see call dailies. How we put the call dailies? Let me here. Where we calculated in our second graph, that is the total number of calls. So this is the total number of calls, that is the grand total. So we divided the grand total by the 23 because this is the total. So 5.29 is the total number of calls we are getting in a day. So what is the 30% of the daily calls? Because that is going to be the night calls. So we can see this is the 1538, but now we are only interested in completing the 90% of the night calls. So that will be again 90% if you convert that. So to 90% B3 into 90%, that will be 1385. And we have again calculated also already calculated that is what is the average call duration. You can see here the average call duration is 198.60. So multiply 90% of night calls into the call duration, we got the working hours. Total work, total work that has been made in the night for our entire day, because here we are doing for the 1 day data. So we converted again seconds into like 3600. So as required will be what? Total work divided by the one employee can do in a day. That is 4.5 hours. So we converted into the round function using the zero, and then we found that okay, we need the 17 employees, right? We found that we need the 17 employees. So we uses 70 to convert into the percentage according to this percentage value. That is 10% in the 9 to 10 p.m. or 11 to 10%. So this will be 17 is equal to 100%. So 1 will be equal to 1.7. So 10 will be equal to 1.7, and likewise. So again we converted our employee round function, that is the integer proper integer. So again, we can see that two employees are increased due to using our agents required functions. Sorry, round function. So what we did it here, we actually converted this chart into a very useful or very easy column chart. So what are the insights after analyzing this data? So let us talk about this. So the manpower planning in the night shift. So peak demands, that is highest need, is the three employees from 8 a.m. to the 9 p.m. Sorry, 9 a.m. The early demand, two employees required from 9 p.m. to 11 p.m. Right? And the low demand is the minimum staff, that is one employee needed between the 11 p.m. to the 5 a.m. So this is the very lowest employee that is needed between 11 p.m. to 5 a.m. You can easily see it in the graph. The gradual increase employees rises again after the 5 a.m. to the 8 a.m. You can see the two employees we needed between the 5 a.m. to the 8 a.m. So the pattern shows that needed at the start and end of the night shift. That is the start of the night shift 9 p.m. to 11 p.m. two employees, and then at the end of the night shift, that is 5 a.m. to 9 a.m. and where 8 to 9 being the highest, that is three employees. So this was it. Very nice task has been given, and we love enjoying this analysis, and I'm highly become a Microsoft. Hello, hello. I'm audible. Hello, hello, hello. Okay. Okay. So it goes down, not a big problem. So what are the conclusion from all the tasks? All the tasks, that is the average call duration, call volume analysis, manpower planning, and the night shift manpower planning. If we come to the conclusions, we can definitely say that the peak demand is the highest need for demand is 11 a.m. to 2 p.m. that requires the 7 agents due to the significant calling flux. Stable afternoon requirement from 2 p.m. to 6 p.m. A consistent need for the 6 agents suggests stable call activity. Lowest demand, that is 8 p.m. to 9 p.m. periods only two agents offering flexibility for the resources allocation. Evening variations, the demand slightly decreased for to 5 to 6% from 6 p.m. to 8 p.m., indicating ongoing but lower needs. Early morning trends, so the peak staffing, that is free staff, is required toward the end of the night shift, 8 a.m. to 9 a.m., and the initial high demand, that is two employees from 9 p.m. to 11 p.m. and 5 a.m. to 8 a.m., reflecting operational handovers. Lowest employees, that is one staff from 11 p.m. to 5 a.m. Okay. So these are the conclusions. Let us talk about the recommendations. So optimize staffing. Increase the agent availability during the peak hours to avoid the exceeding the 10% amendment rate. And the ongoing analysis, regularly review call patterns to adjust the staffing efficiency and ensure the trains are well prepared to handle the peak volume analysis. So these are the some of the recommendations. Regularly keep analysis over the data, how the customers are calling. Make sure the employees are highly trained so that they are able to handle the tough problems or the more complex problems that the customer is calling in some durations, and also increase the staff in the like peak hours to avoid the exceeding the 10% amendment for a better complete success. So that's it. Thank you again very much. Thanks to the Trinity for providing me a very helpful kind of project, and I'm very much confident after doing this analysis of ABC call volume trend. And if any kind of task will be coming of this time, this kind of any kind of, what do you say, like call volume or any customer support, so I will be definitely able to do this. So contact me here. This is my professional email ID or the phone number, my address. That's it. Thank you so much.